Hello, ladies and gentlemen, and welcome to Mr. Salcedo's YouTube videos. Today, what we're going to be going over is how to balance redox reactions using the half reaction method. So sometimes using the oxidation number method, like we talked about, is not the way to appropriately balance an equation because it is happening in an aqueous solution. And so because reactions happen in aqueous solutions, that means that we actually have water involved in our reaction. We have hydroxide ions involved in our reaction, and we have hydronium ions involved in our reaction. So because of all of that, it makes the redox balancing a little bit more difficult. And so in these cases, we need to use what we call the half reaction method for balancing our equations. So we're going to go over how to balance the equations in acidic medium versus basic medium, because in acid you do a certain set of rules. In basic medium, you use a second set of rules. So let's start with how to balance in an acidic medium. The first thing you do is you write your half reactions for your oxidation part and your reduction part. Then balance all of the elements except for hydrogens and oxygens. Then balance your oxygens using water molecules. Balance your hydrogens using H plus molecules, or I guess I should say ions. And then balance your charges by adding electrons. Now, if the number of electrons lost is not equal to the number of electrons gained, we have to multiply one or both of the half reactions by a number, a coefficient that will make the number of electrons gained equal to the number of electrons lost. Now, if you've done all of these correctly, you should be able to add your half reactions together and get your final answer. On the other hand, if you did not do this correctly, then you're probably not going to have a balanced amount of electrons on both sides, which means that you're actually going to have electrons in your final reaction. The point of doing the half reaction method is your electrons should cancel, so your electrons are not included in your final answer. Okay? So let's go over how to do that with this reaction. So we have a dichromate ion, we have nitrous acid, and we're making a chromium 3+ and a nitrate ion. So let's split that into two parts. Okay? So I've got my dichromate and my chromium 3+, and I've got my nitrous acid and my nitrate ion. Now, right here, the first rule was to balance everything that is not hydrogen or oxygen. So here, my nitrogens are balanced. Here, my chromiums are not. So I would need to put a 2 here in order to balance my chromiums. Next step, balance your oxygens using water. So I have 7 oxygens here. That means I would need 7 waters on this side in order to balance it out. Here I have 2 oxygens, here I have 3, so I would need one water molecule to balance out my oxygens. Now, balance your hydrogens. I have 14 hydrogens on this side. That means I need 14 H pluses on that side. On this side, I have 3 hydrogens. On this side, now I need 3 H pluses. Now, I want to balance my electrons. Here I have 14 positives, minus 2, that's a plus 12 over here. Over here I have a plus 6. I need them to be the same. How can I turn a plus 12 into a plus 6 using electrons? I can add 6 electrons. Remember, electrons are negatively charged. On this side, I have nothing. I have no charge. Here I have a plus 3 and minus 1. That's a minus 2. How can I turn a neutral? How can I turn this neutral into something else, right? Here I need to have, here I have my plus 2. I need to make that neutral using my electrons. So I would have a plus 2 for my electrons here. Now notice my electrons are not the same. I have a plus 6, I have a plus 2. That means that I need to make sure I multiply everything by a 3 in order to get these numbers of electrons to be the same. So let's multiply everything here by a 3. So I have 3 of these, 3 of these, 3 of these, 9 of these, 6 of these. Now, theoretically, if I did everything correctly, I should be able to add these together and then start crossing things out, okay? So let's think about what I can, first of all, cancel. So I can cross out my electrons, that's nice and easy. What else can I do? I have 14 hydrogens on this side, I have 9 on this side. That means that overall, if I cross out this 9, I could subtract 9 from here and get my final number of hydrogens. Here I have 7, here I have 3. That means that again, I can cross out this 3, and now I can subtract 3 water molecules from here in order to get my final number. So it would actually look like this. I can count that, good. Count that, good. I have 5 now overall. 14 minus 9 is 5, right? Here, I got my 2Cr, 3 plus. I've got my 3 nitrates, and now I've got my 4 water molecules. 7 minus 3 is 4, and that would give me that. So this should be our complete balanced equation for an acidic medium. Now, one more example. Oh, duh. We need to talk about what was reduced. So chromium was reduced and nitrogen was oxidized. Again, if we're looking at our half reactions before we even did any of this, it makes a lot more sense. But chromium was being reduced, whereas nitrogen was being oxidized.